There's a paste that costs $2 and eliminates battery terminal corrosion permanently in 60 seconds. Not scrapes it away with a wire brush while spreading corrosive powder across the battery tray. Not sprays it with commercial cleaner that neutralizes surface buildup but leaves microscopic deposits that accelerate recurrence. Eliminates it. Dissolves the corrosion at the molecular level, neutralizes the acid residue causing it, and leaves a protective film that prevents future buildup for years. One application on corroded battery terminals, and the white-blue crusty buildup vanishes. The metal underneath is clean, the connection is restored. And because the treatment neutralizes the sulfuric acid residue at the source, terminals stay clean 10 times longer than mechanically scraped ones. This reaction has been documented since 1860. The US military used it on vehicle fleets in World War II. Every mechanic over 60 learned it in vocational training. Before the automotive service industry realized they could generate recurring revenue from a problem, this $2 paste solves permanently. The automotive battery service market generates $18 billion annually. Terminal cleaning, testing, and replacement, services you need repeatedly when corrosion keeps returning. A $2 paste that stops corrosion permanently is not a service they can sell. It is a revenue stream they cannot survive. This is the story of the corrosion cleaner mechanics buried. Welcome to Dr. Rayan Lab. Here is what battery corrosion is, and why scraping creates the problem it claims to solve. The white-blue crust on battery terminals is not dirt. It is lead sulfate and copper sulfate. Crystalline compounds formed when sulfuric acid vapor from the battery reacts with lead terminals and copper clamps. This buildup is electrically resistive. It prevents current flow. Your car struggles to start. Mechanics scrape it with wire brushes. This removes visible buildup, but accomplishes 3 destructive things. It scratches the terminal surface, creating nucleation sites for faster regrowth. It spreads corrosive powder across the battery tray where it continues reacting, and it removes 0 acid residue, the root cause. Within weeks, corrosion returns, often worse than before because the scratched surface provides more surface area for crystal growth. Commercial battery cleaners spray foaming agents that neutralize surface acid. They work temporarily, but they cannot penetrate thick crust. They leave residue that attracts moisture, and they cost $8 to $12 per can, requiring repeated purchase. The compound that actually works attacks corrosion through a 3-stage chemical reaction. Sodium bicarbonate, baking soda, is a weak base. When mixed with water into a paste and applied to acidic sulfate crystals, it neutralizes the acid through acid-base reaction. The sulfate crystals dissolve. The reaction produces carbon dioxide bubbles and water-soluble sodium sulfate that rinses away completely. Equation: H2SO4, acid residue, plus 2 NaHCO3, baking soda, Na2SO4, soluble salt, plus 2 H2O, plus 2 CO2, gas. But here is the mechanism the automotive service industry hides. After the corrosion dissolves, the baking soda leaves a thin alkaline film on the metal surface. This film neutralizes any future acid vapor contact before it can form new crystals. The terminal stays clean because the chemistry preventing corrosion is still active. This is not coating. It is ongoing neutralization at the surface level. One application with proper technique and terminals stay clean for 1 to 3 years instead of 1 to 3 months. The difference is chemical neutralization versus mechanical removal. This chemistry was documented in 1860 by German chemist Robert Bunsen. Military vehicle maintenance used it extensively in W. And the automotive service industry spent 50 years making sure you associate baking soda with refrigerator odors, not with the most effective battery maintenance compound ever documented. Through the U.S. military maintained vehicle fleets under extreme conditions: salt air in Pacific Islands, desert heat in North Africa, Arctic cold in Europe. Battery failure from terminal corrosion was a constant threat to operational readiness. Army vehicle maintenance manuals from 1942-1945, copies preserved at National Archives and military vehicle restoration museums, include explicit battery terminal cleaning protocol. Mix baking soda with water to form thick paste. Apply to corroded terminals. Allow reaction to complete. Visible fizzing. Rinse with water. Dry completely. Apply thin coat of petroleum jelly to clean terminals. This was not suggestion. It was mandatory maintenance procedure performed at regular intervals across entire vehicle fleet. After the war, this knowledge transferred to civilian mechanics. Vocational training programs through the 1950s-70s taught baking soda paste as standard battery maintenance. It was in every auto shop textbook, every apprentice training manual. Then in the 1980s, the automotive aftermarket industry consolidated. Major parts retailers, AutoZone, Pep Boys, Advance Auto began stocking branded battery cleaning products, aerosol sprays, wire brush tools, battery terminal protector sprays. These products worked partially. They generated shelf presence, profit margins, and most importantly, recurring purchases. Spray can runs out, wire brush wears out. Protector spray requires monthly reapplication. By 1990, baking soda paste had disappeared from mechanic training curricula. New generation of technicians learned use battery cleaner spray and terminal brush, recommend terminal protector spray, schedule customer for battery test in 6 months when corrosion returns. The compound did not become less effective. It became commercially inconvenient. One $2 box of baking soda treats dozens of batteries over years. One $10 spray can treats 2 to 3 batteries once. The industry did not ban baking soda. They erased it from training, removed it from service bay procedures, and ensured no mechanic under 40 ever learned their grandfather's method worked better than everything on the parts store shelf. Think about your last battery corrosion experience. You pop the hood. The terminals are covered in white-blue crust. You know this is why the car struggled to start this morning. You drive to auto parts store, buy the $9 spray can and $6 wire brush. Back home, you spray the terminals. It fizzes slightly. You scrub with the wire brush. Corrosive powder flying everywhere, getting on the battery case, your hands, the fender. Terminals look cleaner, but not perfectly clean. Thick crust in crevices remains. 6 weeks later, it is back. Sometimes worse than before because you scratch the surface and spread the powder, or you take it to the shop. Battery terminals need cleaning and testing, $45. They do the exact same scraping and spraying. 2 months later, corroded again, another $45. This cycle exists because chemical neutralization was replaced with mechanical removal that creates the conditions for faster recurrence. Here's exactly what to do. The paste consistency and application sequence determine permanent cleaning versus temporary improvement. What you need: baking soda, sodium bicarbonate, any grocery store brand. One box costs $1, treats 20 plus batteries. Water, small bowl for mixing. Old toothbrush or parts cleaning brush, not wire brush. Wrench to disconnect terminals. Petroleum jelly or dielectric grease for final protection. Gloves and safety glasses. You are working around battery acid. The protocol, step 1. Disconnect battery. Negative terminal first, then positive. This prevents short circuits during cleaning. Set cables aside away from terminals. Step 2. Make paste. Mix baking soda with water in small bowl. Ratio, approximately 3 parts baking soda to 1 part water. Consistency should be thick paste, like toothpaste, not runny liquid. Thick paste stays where you apply it and provides maximum contact time. Step 3. Apply paste. Liberally, using old toothbrush, apply thick coating of paste to corroded terminals and cable clamps. Cover all corroded areas completely. Do not be stingy. The reaction requires adequate baking soda to neutralize all acid residue. Step 4. Observe reaction. Immediately, you will see vigorous fizzing, bubbling. This is CO2 gas release, proof the acid-base neutralization is occurring. Heavy fizzing indicates active corrosion being dissolved. For light corrosion, fizzing stops in 30-60 seconds. For heavy crust, fizzing continues 2 to 3 minutes. Let paste sit until fizzing completely stops. This ensures complete reaction. Rushed rinsing leaves unreacted acid. Step 5. Scrub. Gently. After fizzing stops, use toothbrush to gently scrub away dissolved residue. The paste has already done the chemical work. You are just removing the dissolved material, not scraping metal. Gentle brushing is sufficient. No wire brush needed. Step 6. Rinse thoroughly. Pour clean water over terminals and clamps to rinse away all paste and dissolve sulfate salts. Use liberal water. You want complete rinsing. Let drain. Wipe dry with cloth. Step 7. Inspect. Terminals should be clean metal, lid gray or copper color depending on material. If any white-blue crust remains in deep crevices, repeat paste application on those spots. Step 8. Protect. Before reconnecting, apply thin coat of petroleum jelly or dielectric grease to cleaned terminal posts and inside cable clamps. This provides moisture barrier preventing acid vapor contact with clean metal. Step 9. Reconnect. Positive terminal first, then negative. Tighten firmly. Apply additional thin coat of petroleum jelly to outside of connections. What you accomplished? Chemical dissolution. Every molecule of sulfate crystal converted to water-soluble salt and rinsed away. Acid neutralization. Residual sulfuric acid on metal surfaces neutralized completely. Cannot form new crystals. Protective alkaline film. Microscopic baking soda residue on metal surface continues neutralizing acid vapor contact. Moisture barrier. Petroleum jelly prevents moisture and vapor from reaching metal. Result: terminals stay clean for 1 to 3 years instead of 1 to 3 months with mechanical cleaning. For severe corrosion, battery tray and hold-down hardware often accumulate corrosion powder spread during previous cleanings. Clean these with baking soda paste too. Dissolved corrosion in tray cannot recontaminate terminals. For preventive maintenance, every 6 to 12 months, inspect terminals. If you see any white residue forming, apply a small amount of baking soda paste. Catch it early. prevents heavy buildup. Why this works better: wire brushing, removes visible buildup, scratches surface, spreads powder, leaves acid residue, corrosion returns in 4 to 8 weeks. Baking soda paste dissolves buildup chemically, no surface damage, neutralizes acid completely, leaves protective film. Corrosion prevented 12 plus months. Cost comparison: baking soda method, $1 box, treats 20 plus batteries. Petroleum jelly, $3 a jar, lasts years. Total per battery cost, under $0.20. Commercial spray, bore plus wire brush, $15, treats 3 batteries once. Per battery cost, $5. Shop service, $45 per cleaning requiring repeat every 2-3 months. Annual cost, DIY baking soda, costs $0.50. Commercial products, Farmer 30-60. Shop service, $180-270. Effectiveness: baking soda achieves complete acid neutralization and 12 plus month protection. Commercial methods achieve surface cleaning and 1 to 2 month protection. Retired Fleet Maintenance Supervisor, USPS, Robert Chen, 32 years maintaining postal delivery vehicles, posted on Automotive Forum 2020. USPS Fleet SOP through my entire career. Baking soda paste for battery terminals. Thousands of vehicles, every terminal cleaning used same method. We maintained vehicles running daily routes in all weather: salt, humidity, temperature extremes. Baking soda kept terminals clean, average 18-24 months between services. After retirement, took my car to dealer for complimentary inspection. Service advisor recommended $65 battery service for severe corrosion. I went home, used baking soda method I learned at USPS. Took 5 minutes, cost $0. Terminals still clean 16 months later. Commercial service is not better, it is just more profitable. Robert Bunsen documented it in 1860, establishing acid-base neutralization reactions in foundational chemistry, still taught today. The U.S. military deployed it across global vehicle fleets and WR2s, making baking soda paste mandatory maintenance because operational readiness could not tolerate recurring battery failures. Vocational training programs taught it through the 1970s, ensuring every certified mechanic understood chemical neutralization outperformed mechanical removal. Robert Chen used it for 32 years, maintaining postal fleet, watching baking soda provide 18-24-month protection, while commercial methods required service every 2-3 months. $18 billion in battery service revenue depends on terminal cleaning being recurring service rather than one-time chemical treatment. $45 shop charges depend on mechanics, not telling customers that $0.50 of baking soda paste outperforms $15 worth of spray cans and wire brushes. Automotive parts. Retail depends on branded aerosol products generating recurring purchases when the compound in your kitchen pantry works better and costs 1/30th as much. But acid-base chemistry does not care about part store profit margins. Sodium bicarbonate neutralization does not negotiate with service department revenue targets. And baking soda costs $1 whether the automotive industry wants you to know it works or not. If this changed how you look at your corroded battery terminals, the $15 you spent on spray and brush last week, or the $45 shop service you have been paying quarterly, subscribe to Dr. Rayan Lab and share this now. Every share cracks 50 years of training erasure that removed superior chemistry from mechanic curricula to protect recurring service revenue and branded product sales. Next Vault, the $1 powder that removes oil stains from concrete permanently using the same chemical neutralization, documented in industrial cleaning since 1920, never mentioned in consumer driveway cleaning products, despite being more effective than $18 degreasers. Subscribe. The lab never closes. This is Dr. Rayan Lab. The chemistry is yours.